So as you know that in the last class I covered regarding functional dependency and normalization. As I told, normalization is the process which is used to reduce the redundancy problem and also the update anomalous problem. To resolve those problems you can go for normalization process. So in the normalization process you will learn about the different normal forms. Normal forms are like constraints. You have to follow those constraints and according to those constraints you have to find the solution. If you create the relations and according to that constraints, if it is created, if that constraint is fulfilled, then what are the relation design you will get know that is having the good relation. So first we'll start with first normal form. First normal form, it is the normal form in the normalization process. It is having one constraint. What is that? Attribute values must be atomic. So what are the attributes you are having? No, that must be indivisible. Further dividing the attributes is not possible. That's why it doesn't support composite attributes. And what are the values you will enter for the attribute? No, it must be single valued here. It supports atomic and single valued for the attributes here. So if you want to achieve this first normal form, what procedure you have to follow? You have to remove the attributes and place in separate relation. If you want any attribute, that attributes you want as a further divisible, then what is the procedure? You have to create or you remove that attribute and you add the multiple attributes instead of using the single attribute. That's why in the this one in employee, that name you have further divided as a F name and L name and middle initial. Those things you are taken as a separate attributes here. And any attributes if it holds multi-values, and that one if you want in your relation and it violates your first normal form. First normal form tells what it is. It must be atomic and values must be single valued. In that situation, what is the procedure you have to do? You check which attribute violates that first normal form constraint and you extract that from the relation and you place that attribute in a new relation as a separate relation. While extracting as a separate relation, you expand the key. Expand the key means what? Along with that attribute you take the primary key attributes of this relation. Which attribute violates, that attribute you have to extract, and along with that in that relation which attribute is primary key, that one also you have to extract or remove from that relation, and you have to create a new relation and you add up this attribute with the primary key attribute. So use several atomic attributes here as I told earlier. So if you want to divisible, if you want to divide the any attributes, then instead of taking that attribute as a single attribute, you divide as a multiple attributes like name. Name is further divided as a several atomic attributes like F name, L name and the middle initial. Like this, if you follow, then you can achieve this first normal form here. So it does not support nested relations. So in the first normal form it does not support the nested relation. So if you have the relation with the nested relation attributes, then what is the procedure you have to follow? If you want in the first normal form, first you have to remove the nested relation attributes into a new relation because it does not support, and propagate the primary key into it. If you want the nested relation attributes, those attributes also you have to remove from the relation and you have to create a new relation. That relation contains this attribute and along with the primary key of the relation. So unnest relation into a set of one normal form relation. If you are hanged in nested relation, that one you have to separate it as a or distribute or divide as a multiple relation. That is what we call as a unnest relation into a set of multiple relation. All that relation must be in the first normal form here. This is one example here. Department table contains attributes are D name, D number, manager assistant, and D location. So as you already know that same department may be located in multiple locations. Then for the D locations you will get the multiple values. But as we know that in the first normal form it doesn't support multi-values. So but for the D location you want the multi-values. So as we know that in the first normal form all the attribute values must be single valued. But here for this D location we get multiple values because for same department may be located in different locations. As this D location violates your first normal form here. So then what is the procedure you have to follow now? If it is not in the first normal form, you check which attribute violates your first normal form. This attribute violates your first normal form. Then what is the procedure you have to do now? So you have to remove this normal form here. So for that here I taken the example. So for example, if I enter the values for the department, this research department is located in multiple locations. That is what. So here these are the three different locations where this research department is located. So then for this one we'll get the multiple values here. But this multiple values are not supported in the first normal form here. Okay. So as I told, in the normalization process, you are going for which purpose? To reduce the redundancy here. So that's why in the first normal form, it doesn't support multi-valued. See here, for example, if it is take as a repeatedly, so this department location, Bellary, Sugarland, and Houston. These are the three different locations where this department is located. So then this information, this informations you are entering how many times? Same informations you are entering the multiple times here. So then this is what it is. This is creates the redundancy problem here. Same information you are repeatedly entering multiple times here. And this creates the redundancy problem here. So to prevent from such type of the problem, first normal form tells what it is. So it supports only single valid here. So if you want this relation in the single relation, what is the procedure you have to do? So you check which one violates that relation. You have to remove from this department table, and you have to create a new relation. So that's why in the employee company database, you are having the attribute that is the department location is also one new relation here. That is the DPT location as a new relation I'll take here. And in this relation, department location as a new relation. And this relation contains the attributes of what? This new relation contains the attributes. So that one you have to take which attribute violates your this one. So D location, then that one you add in the new relation as a one attribute. As I told earlier, you separate that attribute from the single relation and you create a new relation, and that relation contain attributes which violates the first normal form along with the primary key. So in this table, which one is primary key? D number is the primary key here. So department location is the new table and attributes of this one is the D number and the D locations here. So now if I create this one, I divided as a two relation. One relation is what? D name, D number and manager assistant, and another relation I given as a department location, and attributes of that one is the D number and the D location here. So in that situation, what happens here is now this relation is in the first normal form, and here if I repeat, instead of repeating the D name and manager assistant, only department number is repeated in the department location table. Because only 55 is repeated 3 times because the same department may be located in multiple locations. So instead of repeating the department name and manager assistant, only department number is repeated here, as you are reducing your redundancy here. So this is about your first normal form. So in the first normal form, what it tells? your attributes must be holds the single valued. If any attribute holds the multiple values, then what is the procedure you have to do? That one you have to extract from that relation and you have to create a new separate relation, and that relation contain attribute which violates along with the your primary key. So then it fulfills your first normal form. So this is about your first normal form. Next, the second normal form. So what second normal form tells? Second normal form based on the concept of full functional dependency. Fully functional dependency. So what actually fully functional dependency? Fully functional dependency means what? Remaining all the attributes are functionally fully functional dependent on your one attribute, that is your primary key. If I take your student information, in the student information, so USN number is there, name is there, address, okay, functional dependency already know that, address, your branch, and okay, your mobile number, birth date, all these attributes are functionally dependent on, okay, name or USN here. So then if I take that functional dependency, now I can tell that is what? Among name and USN is your primary key and name is your secondary key here. So now this address, branch informations and your date of birth, all these attributes are functionally dependent on USN number and the name here. So name is your secondary key and USN is your primary key here. So now all these informations are fully functionally dependent on USN number and partially dependent on name here. If it is the member of the key here, it is the candidate key as a secondary key. But all these informations are, it is partially dependent here. So that is what we call as a partial dependency. Is it clear now? Functional dependency means, fully functional dependency means what it is? USN. All the other attributes are fully functionally dependent on USN number. Partially dependence means what? All are partially dependent on name here. But in the second normal form, what it tells, let's see. The relation schema R is in second normal form if every non-prime attribute A in R is fully functionally dependent on the primary key of R. So prime attributes means what it is? It is a member of candidate key. So non-prime attributes means what it is? It is not a member here. So such type of the attribute, okay, if it is fully functionally dependent on primary key of the R, then you call that relation as in second normal form. So if it is not there, okay, second normal form when it is required, all non-prime attributes are associated only with part of a primary key. So all are associated with the only primary key, then you call that one as a fully functionally dependent, then you call that relation as a second normal form here. So this is one example. So I taken the relation name as an employee and purchase. Actually these are the two entity types. These two entity types I combined as a single relation and I want to check whether it is in the first normal form or not or whether it is in the second normal form or not. As all the attributes are atomic, that's why it is in the first normal form and it holds the single value. For the first normal form condition is what? Attributes must be atomic and it must be single value. If all these attributes are atomic and it is single value. If this relation is in first normal form. Second normal form is what it is? All the functional dependency must be fully functionally dependent. Here I taken the three functional dependencies, FD1, FD2 and FD3. FD1 tells what it is? Hover. Okay, hover is functionally dependent on P number and SSN. And second functional dependency what it tells? E name. Okay, E name is attribute, it is functionally dependent on SSN. And third functional dependency what it tells? P name and P locations are functionally dependent on P number here. Okay, so now here this relation. Okay, as I take on this relation, so in this relation, for example, if I take hours, okay, hours is fully functionally dependent on P number, and hours is fully functionally dependent on SSN. SSN and P number combination I taken as a primary key here, and this hour is fully functionally dependent on P number, which implies works on which project. Based on that, I can tell that if this employee is working on this project on how many hours. That information is depends on employee and also project number. Next, I'll go to the P name. That's why hours is fully functionally dependent on P number and SSN. If I know only P number, I can't tell that how many hours that employee works. If I know the SSN number, I can't tell that that employee works on which project how many hours. Okay, if I know this two, with the combination of this two, I can tell that if this employee works on this project, this much of hours here. So that's why this hour is depends on SSN and also project number. Next, I'll go to email, employee name. Employee name is fully functionally dependent on SSN. As if I know the social security number, then I can get the e-name here. If this e-name is employee related information and it is dependent on your primary SSN. This nowhere concerned with the P number. E-name is nowhere related with the P number here. So that employee if it is not working on any project, then also employee is existing here. So now that employee may be peon or any other person here. So that peon is not working on project number. Then this peon is not related with this project number, but that employee is having the SSN here. In this situation, e-name is what now? E-name is fully functionally dependent on SSN. Okay, it is fully dependent on SSN. Then what about your P number here? Okay, what about your P number here? So e-name is fully functionally dependent on SSN. Then this e-name is because combination of SSN and P number you are taken as a primary key in this relation. But e-name is fully functionally dependent on SSN. Then this e-name is partially dependent on P number. Okay, this e-name is partially dependent on P number. It is fully functionally dependent on SSN and partially dependent on P number. In that situation, is it in second normal form? No, because it is not in the second normal form. What second normal form tense? Second normal form tense, that is what? It supports only fully functional dependency. It doesn't support your partially functional dependency. That's why this relation is not in the second normal form here. In the same way, P name, project name is fully functionally dependent on P number. Okay, and P location is also fully functionally dependent on P number. But these two attributes are partially dependent on your SSN. Okay, so is it clear now? P number is fully functionally dependent and then what it is? P name and P location or the information it is related with the P number. Whereas V name is the information related with the employee, that's why it is related with SSN. So this is the relation and it is not in the second normal form. Which are the attributes violate to a second normal form? This E name and your P name and your P location. Now if I want this relation in the second normal form, what is the procedure I have to follow? I have to decompose this relation into multiple relation to get this second normal form, that to be in the fully functional dependency. As I told, this hours is fully functionally dependent on SSN and the P number. That's why I created one relation. I decompose this as a new relation, EP1, and functional dependencies are here. SSN, P number determines hours here. And as I told earlier, e-name is fully functional dependent on SSN only. If I remove this project number, it doesn't make any difference to your functional dependency. That's why I created the relation SSN and e-name is fully functional dependent on SSN. In the same way, P name and P locations are fully functional dependent on project number. If I remove the SSN, it doesn't make any difference to your functional dependency here. So that's why that relation is P number, and P name and P locations are functionally dependent on this P number here. Like this, if it is not in the second normal form, you have to convert that into second normal form by decomposition. After decomposition, what are the relations you'll get? No, that relation must satisfy or holds that fully functional dependency. As this relation holds the fully functional dependency, this relation also holds fully functional dependency, and this relation is also holds fully functional dependency. Now, these three relations are in second normal form and also in the first normal form. Like this, while designing any relations, you have to check whether it is in the first normal form or not, whether it is in second normal form or not. If it is not, you have to convert that relations into second normal form by decomposition. So this is about your second normal form. Is it clear now?